Good morning, dear students. Today's discussing topics are: first one, motion of objects under the influence of gravitational force of the earth, and second one is related numerical. Before going to introduction to the topic motion of objects under the action of gravity, now you have to recollect the most important learned part from last class. It is free fall. If the freely falling body is under the influence of gravity, you can answer it is yes. Surely free fall is under the action of gravity. So, motion under gravity refers to the movement of an object whose vertical motion is affected by the presence of gravity. As the value of acceleration due to gravity is constant near the earth, the equations of motion of a uniformly accelerated body, which you have learned from the chapter motion, would be valid for free fall motion. If we replace acceleration A by acceleration due to gravity G, we have the three equations of motion of a uniformly accelerated body, which are the first one, V is equal to U plus AT, second one, S is equal to UT plus half AT square, and third one, V square is equal to U square plus 2AS. Now I am going to discuss on topic motion of objects under the influence of Earth's gravity. Let an object is falling towards the Earth with initial velocity small letter u. Let its velocity under the effect of gravitational force changes to small letter v after covering the height small letter h in time t seconds. Let acceleration of the object which is obtained by this gravitational force be small letter g. Here we have replaced small letter a by small letter g. Then the three equations of motion can be represented as velocity after t seconds, v is equal to u plus gt. This is equation number 1. Height covered in time t seconds, h is equal to ut plus half gt square. This is equation number 2. And relation between v and u excluding time t, v square is equal to u square plus 2gh. This is equation number 3. The value of g is taken as positive in case of an object when it is moving towards earth, and taken as negative in case of the object when it has thrown in opposite direction of the earth's gravitational force. Here h is the height of the object from the ground. Now you are going to see how to derive equations of motion of a freely falling body. The newly formed equations are again written as v is equal to u plus gt, h is equal to ut plus half gt square, and v square is equal to u square plus 2gh. These equations undergo a small change when we apply them to the motion of a freely falling object. The above equations are modified as v is equal to gt, this is equation number 4, h is equal to half gt square, this is equation number 5, and v square is equal to 2gh, this is equation number 6. Here u is already eliminated because initial velocity of a freely falling body is equal to 0 and g is positive. Now, let me discuss on how can derive equations of motion of a vertically projected body. What is a vertically projected body? It is the body which has thrown upwards. Suppose an object which has thrown upwards with initial velocity small letter u. Let its velocity under the effect of gravitational force changes to small letter v after covering the height h in time t. Let acceleration of the object which is obtained by this gravitational force be g. We have the general equations of motion which are the v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Here we have to replace a by g from above equations, and g will be negative because acceleration due to gravity is in opposite direction of the gravitational force. So it should be considered to be negative. That is, the body's motion or velocity of the moving body is opposed by gravitational force. Then the general equations of motion are modified to be v is equal to u minus gt, h is equal to ut minus half gt square, and v square is equal to u square minus 2gh. Here s is replaced by h because the body has travelled vertical distance h. The equations of motion of a vertically projected body are again written as v is equal to u minus gt, this is equation number 7, h is equal to ut minus half gt square, this is equation number 8, and v square is equal to u square minus 2gh, this is equation number 9. It is essentially you have to learn two important terms. First one is time of action, second one is time of descent when you have studied the motion of a body under the action of gravity. What is time of action? Time of action is the time taken by a vertically projected body to reach on maximum height. Then what is time of descent? It is the time taken by a freely falling body to reach on the ground. Now let me go to the numerical part. Before that, one important matter I want to say you, before you are going to solve this kind of numerical, you have to know how to use the set of equations of motion situationally. So it is very essential to study the equations of motion of a freely falling body and a vertically projected body. And also, writing practice is very important. In solving the given numericals, the modified form of general equations of motion are applied instead of using general form of equations of motion directly and then after their modification. Question number 1. A stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. What is its solution? According to the equation of motion under gravity, we have v square is equal to u square plus 2gh. Here the object is a freely falling body. For this expression, g is positive and already we have considered the sign convention for g in forming this expression of a freely falling body. Given that initial velocity of the stone u is equal to 0, height of the stone is equal to 19.6 meter and acceleration due to gravity g is equal to 9.8 meter per second square. What is its final velocity v? We have used the expression here v square is equal to 0 square plus 2 into 9.8 into 19.6. Then v is equal to 19.6 meter per second. Hence, the velocity of the stone just before touching the ground is 19.6 meter per second. See the second question. A ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate first one, the maximum height to which it rises, and second one, the total time it takes to return to the surface of the earth. What should be solution? Here, the body is a vertically projected body. So we have to use these equations conveniently. V square is equal to u square minus 2gh, where ub is initial velocity, vb is final velocity, hb the height achieved by the ball, and gb is acceleration due to gravity. First we have to find the maximum height reached by the ball. At maximum height, final velocity of the ball is equal to 0. That is, v is equal to 0. Given that u is equal to 49 meter per second and g is equal to 9.8 meter per second square. Here g is negative acceleration due to gravity, as the body is a vertically projected body. But we should not substitute the negative value of g in the expression v square is equal to u square minus 2gh. Why? Because this derivation used the sign convention for g earlier. Let h be the height attained by the ball. We use the equation v square is equal to u square minus 2gh. On substituting the values of v, u and g, we get 0 square is equal to 49 square minus 2 into 9.8 into h. Then h is equal to 49 square divided by 19.6 is equal to 122.5 meter. Next we have to find the total time taken by the ball to return to the surface of the earth. Let small letter t be the time taken by the ball to reach the height 122.5 meter. We have to use this equation v is equal to u minus gt. Here we get 0 is equal to 49 minus 9.8 into t. Then 9.8 t is equal to 49. So t is equal to 49 divided by 9.8 is equal to 5 seconds. Remember that time of ascent is equal to time of descent. Therefore, total time taken by the ball to return is equal to 5 seconds plus 5 seconds is equal to 10 seconds. Third question is, a stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground, given that acceleration due to gravity g is equal to 9.8 meter per second square. How to solve this question? Here we have to use the equation v square minus u square is equal to 2gh. As the stone is a freely falling body, so its initial velocity u is equal to 0 meter per second. Given that height of the stone h is equal to 19.6 meter and acceleration due to gravity g is equal to 9.8 meter per second square. We have to find its final velocity v. By using this equation, v square minus u square is equal to 2gh, and by substituting the values of u, g and h, we get v square minus 0 square is equal to 2 into 9.8 into 19.6. So v square is equal to 2 into 9.8 into 19.6. By taking the square root, v is equal to root of 19.6 whole square is equal to 19.6 meter per second. Hence, the velocity of the stone just before touching the ground is equal to 19.6 meter per second. And fourth question is, a ball thrown up vertically returns to the thrower after 6 seconds. Find A. the velocity with which it was thrown up, B. the maximum height it reaches, and C. its position after 4 seconds. How to solve this question? Here, the ball takes a total of 6 seconds for its upward and downward journey. It is the sum of time of ascent and time of descent. You know that time taken by the ball for its upward journey is the time of ascent, and time taken by it for its downward journey is time of descent. It is equal to 6 seconds. It is the time of flight. So time of flight is sum of time of ascent and time of descent. Hence, it has taken 3 seconds to attain the maximum height. It is time of ascent, since time of ascent is equal to time of descent. And also we know that the final velocity of the ball, which is at maximum height, v is equal to 0 meter per second. Acceleration due to gravity, g is equal to 9.8 meter per second square. First we have to find the velocity with which it was thrown up. We have to use the equation v is equal to u minus gt, because the ball was thrown up vertically. On substituting the values of v, g and t, we get u is equal to 9.8 into 3 is equal to 29.4 meter per second. Hence, the ball was thrown upwards with a velocity of 29.4 meter per second. B. Find the maximum height reached by the ball. Let the maximum height reached by the ball be h. We got initial velocity during the upward journey of the ball. It is u is equal to 29.4 meter per second. And also, you know that its final velocity v is equal to 0 and acceleration due to gravity g is equal to 9.8 meter per second square. Here we have to use the equation of motion h is equal to ut minus half gt square. On substituting the values of u, t and g, we get h is equal to 44.1 meter. Remember that it should not put negative value for g in above expression. The same reason which was discussed during solving the previous numerical. And see, we have to find the position of the ball after 4 seconds. Here, ball attained the maximum height after 3 seconds. After attaining this height, it will start falling downwards. In this case, its initial velocity u is equal to 0. Here we have to find the position of the ball after 4 seconds. It is the distance traveled by the ball during its downward journey. In time, t is equal to 4 seconds minus 3 seconds is equal to 1 second. You know that after 3 seconds, it is in downward journey. Then, what should be the distance traveled by the ball in 1 second? Here we have to use the equation of motion h is equal to ut plus half gt square. Since the ball now is a freely falling body. On substituting the values of u, g and t, we get h is equal to 4.9 meter. It is the distance traveled by the freely falling ball in time t is equal to 1 second. Then what should be the position of the ball above the ground? It will be equal to total height minus the distance traveled by the ball in time t is equal to 1 second. That will be equal to 44.1 meter minus 4.9 meter is equal to 39.2 meter. Dear students, you know today class has focused to the derivation part and numerical. You have to practice this part thoroughly. Today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.